Hello, welcome to Nomis Academy. In this video, we are going to be solving problems under Theorem 2. In the previous video, we stated Theorem 2 and it says that the arc or the angle which an arc subtends at the center of a cycle is twice the angle it subtends at the circumference. So we are going to be using that principle or idea to solve problems under cycle theorems. So let's pick the first example. Example 1. It says that P, R, and S are points on a cycle center O. If POR angle at O is equal to 150 degrees, then we're asked to calculate PSR. We're asked to calculate PSR. To understand this question correctly, we need to take a diagram. Okay, so we can call here the center of the cycle, which is O. Now they said 3 points PRS. So let me call here P, call here R, and this is S. So this is PRX respectively. So an angle is formed at the center POR, which is 150 degrees. And then we also have another angle formed at the circumference of the cycle at point S. So now we are asked to find PSR, that is angle formed at the circumference of the cycle. Now you remember Theorem 2, it states that according to Theorem 2, we say that POR is 2 times of PSR. So with that idea, we are going to solve the problem, and it's a very simple one. So POR is 150 degrees. And here we have P2 multiplied by PSR. So to find PSR, we divide both sides by 2. We divide both sides by 2. 2 cancel 2. So PSR is equal to 150 divided by 2 is 75 degrees. So the angle formed at this point is 75 degrees. So you can see that the idea of Theorem 2 has enabled us to solve the problem with ease. Can we pick another example? Okay, let's pick another example. Let me clean this side. Example 2. It says that L, M, and N are points on a cycle centered at O. Now N, M, angle at MO is equal to A, and NLO is equal to B. Find the obtuse angle MOL in terms of A and B. Okay, so we have a problem here to solve. Okay, LM and N are points on a cycle center O. So let's draw a cycle. We have a cycle. Okay, and this is the center of the cycle. All right, so let's call here L. We take here to be M, and then we take the upper part to be N. Now, NMO, NMO is A, and NLO, we have it to be B. Now we are asked, the center is O, we are asked to find the obtuse MOL. So this is the obtuse MOL. So how do we go about that? All right, first and foremost, from Theorem 2, we know that MOL is 2 times of MNL. Okay, so this is proven. We know from Theorem 2 that this idea holds. So let's move on. Now we can do some just simple construction. Okay, join N and O. Join N and O. So when you join that, you form 2 triangles. So we can now say that the triangles N, M, O and N, O, L are isosceles. So they are isosceles triangle. It then means that the base angles of these isosceles triangles are equal. So this side angle at N is A, while this other side is also B. Okay, is also B. So now we have, remember we are asked to find MOL. Since we know that MOL is 2 times of MNL, first and foremost, MNL is equal to A plus B. A plus B. A plus B. So to find MOL, MOL is equal to 2 times of what we have as MNL, A plus B. So this is the final answer according to the question. So we should find the obtuse angle MOL in terms of A and B. So this is the final result. So once again, you remember the principle or the theorem that says that an arc or even a chord can subtend angle at the center, and that angle formed is 2 times bigger than the angle formed at the circumference of the cycle. Thank you for watching. See you next time. Bye.